Good morning. Welcome to lecture number 4 on integration. My name is Charles. The presentation outline will look as follows. We'll briefly look at the introduction to integration. We'll look at how to integrate a constant, then a variable, and then we'll look at some of the standard integrals. Finally, we'll look at definite integrals. Integration is a process of summation or adding parts together, and usually an elongated S, which is shown by this symbol, is used to denote integration. And the process of integration is essentially a reverse process of differentiation. In differentiation, if f of x is equal to 2x squared, then the derivative of this was 4x. But when we do the integral, it's basically take the 4x back to 2x squared through that process. And that is basically what we are doing in integration. So let's look at the integration of any constant. Integration of any constant is that constant multiplied by the variable of integration. So it doesn't matter the variable of integration. This variable of integration here could be x, it could be t, it could be u, it could be v, it could be u, and so on. For example, if you are given a constant 4 in this case, to integrate this constant with respect to x, you just have to check the variable of integration. In this case, it is x. Therefore, it will be this constant 4 multiplied by that variable of integration x as your solution. You can have another one. Suppose you asked to find the integration of 100 with respect to dt. So it will be this same variable minus 100 multiplied by the variable of integration, which is t as your final answer. Next type, which is basically integration of variables. For integration of variables or integral of the form ax to the power n, which is basically a variable, this can be calculated by noting that the integration a to the power x to the power n, basically what you do is basically you take this n, add a 1 to the n, and then the sum of n plus 1 is divided by ax to the power n plus 1 as shown here. And each time we add an arbitrary constant to c as given in this function. So this rule is true when n is a fractional value, or it's a 0, or a positive one, any negative integer. But we have one exception when n is equal to -1. So imagine a case where n is equal to -1, then this would become x -1 plus 1, which gives us -1 plus 1 down, and then you're going to have 8x to the power 0 divided by 0, which is basically infinite. So such a product would not be possible to do when n is equal to -1. Let's do some examples under here. So example number 1, in this case, using integration of variables, given a variable fixed 3x to the power 4 dx, then we are asked to integrate. In this case, 4 is our n, therefore it will be n plus 1, which is 4 plus 1, giving 5. And then this 4 product here divided here, which is basically 5. And then the x there will have increased from x to the power 4 to x to the power 5 plus a constant as the answer. Let's consider a second example in this case. In a case where you are supposed to integrate the variable 2 over x squared dx, this part here can be rewritten as 2 times x to the power minus 1. And then this is now in the standard format. Therefore, you can integrate this as 2x minus 2, which is your n in this case, plus a 1 divided by minus 2 plus 1. And simplifying this, you get 2x to the power minus 1 divided by 1, which is the same as negative 2 over x. Let's do another example, which is example number 3. Given an integral root of x dx, the first thing is to break this. We know that root of x, in this case, is the same as x to the power half, just like root of 4 is the same as 4 to the power half. Therefore, by writing this, we have the root of x to the power half dx. Again, this is now in the standard format. This becomes our n, so n plus 1, which is this part, divided by half plus 1. And when you add this to, so this will now be reduced to x to the power 3 over 2 after adding half plus 1, and then divide by 3 over 2, which can be simplified as 2 over 3 root x to the power 3 plus a constant. Note also here that this c is an arbitrary constant because we will not put the limits of the integration. But the moment you put the limits of integration, the c will disappear. Another example worth noting is a scenario where when you have a sum of several terms, the same integration can be done by integrating term by term. Each of these terms will be integrated separately. The integral of this part is this part, plus the integral of 2x squared, which will give you this part, and the integral of the constant 5 will give you 5x as your final answer. So we will have the following standard integrals that will be used. For variables, it's that. For trigonometric functions, it's that. All the way up to there. And for exponential and logarithm functions, these are given as standard integrals. So let's do some examples involving standard integrals. In the first example, which is 4 cos 3x dx, you will notice that you have a constant here, which is basically a coefficient of cos 3x dx. This one can be taken out of the integral sign. Then you integrate this, the cos 3x dx. And when you take the 4 outside the integral sign, this is what you have here. And then integrating cos 3x gives us sine 3x divided by the 3, which is coming from there. So you divide it here, then simplifying this part of the equation, we're going to get 4 over 3 sine 3x plus c as the integral. The second example is 5 sine 2 theta d theta. You are integrating with respect to theta. Again, this 5 is a coefficient. It can be taken outside the integral sign. And then you have 5, which is basically this 5 here. Then the integral of cos of sine 2 theta is minus cos 2 theta divided by this 2 here. And then simplifying this, you get minus 5 over 2 cos 2 theta plus c. Next, let's look at more examples now involving sec and cosec squared. And then you have, in this example A, 7 sec squared 40 dt. Again, what you can do here, this 7 can be factored out, which is what you have here as your 7, multiplied by the integral of sec squared is tan but because tan 40 divided by the 4 here, okay, simplifying this, you get 7 over 4 multiplied by tan 40 plus c. Again, we are basically borrowing this from this standard integral for sec squared. The next example, which is 3 integral cosec squared 2 theta d theta. What you will notice here is that this 3 is already outside. Therefore, when we do the integral, it remains outside. But the integral of cosec squared, according to the standard here, cosec squared ax dx is 1 over cot A, where the A is coming from there. Therefore, in this case, we're going to have minus cot 2 theta divided by the 2, where this 2 again is coming from there. And then simplifying the coefficient here, you get minus 3 over 2 cot 2 theta plus c as your integral. Next, let's try an example involving an exponential functions. If you are given an exponential function 5e to the power 3x dx, and we are asked to integrate this. This 5 here becomes the coefficient, can be taken outside the integral as number 1, which is what we have here. Then the integral of e to the power 3x is e to the power 3x divided by the 3. So this 3 divides here. And then simplifying this, basically you're going to get 5 over 3 e to the power 3x plus c as your final answer. Equally, on example number B, you are given the integral 2 or integral of 2 divided by 3 exponent 4t dt. You can factor out the 2 over 3 outside here as shown here. And then you can rewrite this exponent. You can rewrite this exponent in terms of by taking it up. Then when you do that, this becomes e to the power minus 4t. So the positive 4 here will change into negative 4t when it is being multiplied. And then now with your 2 over 3 already outside the brackets, you can now integrate e to the power minus 4t, which gives you e to the power minus 4t divided by negative 4. Therefore, you have this as 1 over minus 4. Simplifying this further, you have minus 1 over 6. Basically, initially, when you simplify this part, you're going to get 2 over minus 2 over 12 e to the power minus 4t plus a constant, which then reduces to 2 here, 1, 2 here, 6, which is basically negative 1 over 6 e to the power minus 4t plus a constant, which can also be written as, to remove the negative here, this can be written as simply negative 1 over 6 e to the power 4t plus a constant as your final answer. Next, let's look at definite integrals. Integrals containing an arbitrary constant c in their results are sometimes called indefinite integrals because they do not have a precise value that can be determined. Now, when we talk of definite integrals, these are integrals whose limits are known. It can have a limit of, say, 0 to 4, 0 to pi, 0 to 2 pi. And the expression is normally written. We normally write this expression as, in this format, where we use curly brackets. If this is 0 to pi, it means the way to simplify this, wherever there is x, you put first the upper limit, 4 minus, again you put the 0 here, this will be 4 minus 0 wherever you have x, and then simplifying this, you get simply 4. So this is known, the b here is called the upper limit, while the a here is called the lower limit. So let's do an example to illustrate how we use definite integrals. Let's assume that we are given an example a here, where we're supposed to integrate from 1 to 3 being the upper limit and 1 being the lower limit, x squared dx. So in the first example here, what you do is integrate this part first. You're going to get x to the power 3 over 3, right? Plus a constant, though you can choose to ignore all these constants. But you see, as you will see later on, the constants cancel themselves out. So if we just put x to the power 3 over 3 with the upper limits 3, the limits from 1 to 3, then wherever you have x, you substitute your upper limit minus, again you substitute the lower limit where you have x. So in this case, I substitute this upper limit here, which is what I have here. Everything else remains the same, minus the same expression, I put the lower limits, which is 1 in this case, where there is x. So this one goes there. I have 1 to the power 3 over 3 plus c. Simplifying it further, this will give me 3 to the power 3. It's basically 27 divided by 3 plus c minus, I put now where there's a 1, I'm going to have 1 over 3 plus c, and this is going to give us 7 over 3 minus 1 over 3, then you have plus c minus c, which will basically cancel. Then you're going to have 26 divided by 3, which is simply 8, 2, and 2 over 3, which is basically similar to that final answer. The next example is where you have integrating from 1 to 2 for exponent 2x dx. Again, you can take first of all the 4 outside. So you're going to have 4 integral e 2x dx from 1 to 2. When you integrate this, you're going to get 4 exponent 2x divided by 2, and this is from 1 to 2. Simplifying further, this is going to be 4 over 2, then exponent 2x, the limits 1 to 2, which is basically what we have here. And then you can put the upper limit wherever you have x. So in the first one, if we put the upper limit, okay, maybe before we do that, then you can further simplify this to give us 2 e 2x from 1 to 2. So here this will be 2, and putting the limits, you put the 2 wherever there is an x. Like in this case, you are going to have 2e to the power 4 minus, put the 1 where there is x again, it will be e to the power 2 times 1, which is 2. And simplifying what is inside the brackets and multiplying by 2, you are going to get 94.42 as the final. This has been the reference that we have used. Thank you for listening.